Hey everybody, I'm Jake, here with Sarah, Ryan, Sam, and Madeline for our project Velomatique.
Countless cyclists around the world can experience errors or difficulty with accurately shifting, which can lead to losses in efficiency, excessive wear on components, and unneeded overexertion for the rider to ensure. What if there was a product to enhance both new and veteran riders' cycling experiences by suggesting when to shift?
Look no further than Velomatique, a proactive electronic system that recommends when to shift by using a combination of real-time sensor data and offline geospatial data. Our system determines the upcoming slope profile of the terrain and where the rider will be relative to the profile based on their speed. In this way, the system can recommend a gear change prior to reaching the slope.
In order to be able to properly reach our solution, we first have to establish our stakeholders and customer base, which are primarily composed of regular commuters and new cyclists, as well as our goal of bike shore organizations. Contact with each of these groups has allowed us to build a clearer picture of what the market needs and how to achieve these needs. The majority of the stakeholder requests for Velomatique were based on product efficiency, reliability, battery life, and overall ease of use and interaction.
Our final system will be composed of two mounted hall sensors, a central housing, and a heads-up display. The housing for the sensors, Raspberry Pi, accelerometer, GPS, and eventually batteries will be composed of two components, the main housing and the mounting plate. The mounting plate simply attaches to the water bottle cage mounts on the frame, then the outer shell slides over top as shown.
The electrical system consists of our brain, the Raspberry Pi 3B+, a GPS unit, and two Hall effect sensors. To recommend when to shift, we have to identify which gear the user is currently in. We accomplish this by taking the ratio of the RPM of the wheel from this purple Hall effect sensor and the RPM of the drivetrain from this orange Hall effect sensor. The ratio of these two speeds is unique to each combination of gears. We found the current gear ratio using this code and setup. The magnet that I'm holding in my hand in the video is attached to the wheel. As it passes by the hall, we record the frequency and spit out the RPM and bike speed. As a note, throughout the project, we used Python. Getting our GPS coordinates was vital to our project in order to obtain accurate positioning for our predictive program. Through this code, we returned the longitude and latitude for subsequent sections of the project.
One big part of the software development was developing a system that takes both the elevation data as well as the bike sensor data to determine the upcoming slope profile and make predictive decisions about what the rider should do next. In the video, we did demonstrate our system's recommending shifts in 3 different scenarios. In our first case, we have inputted GPS coordinates that have predicted a steep uphill that is about 5 seconds ahead of where the rider is currently if they were riding at 5 meters a second. Once the rider has gotten to the steep uphill ascent, our system shows that the rider should downshift to first gear to be able to ride up the hill.
In this next case, we inputted coordinates of a flat region near the Vancouver airport and predicted the future coordinates 5 seconds in front of the rider. Our software suggests that a rider should not shift because they are on flat ground and they are riding at a good cadence. For our last case, we tweaked the cadence to a value that is outside our acceptable range, meaning the rider is pedaling too quickly and exhausting themselves. Our code makes a prediction to shift up regardless of the upcoming terrain. Most current automatic bicycle shifting systems that have been developed to date do not address the issue of shifting on a steep hill, which causes the drivetrain to bind due to high torque. Our system prevents this from happening altogether by creating a system that looks into the future. We have created a system with the potential to maximize efficiency like never before.
In the future, we plan to make Velomatique a fully automatic bike drivetrain that shifts proactively without user input. This would greatly increase accessibility into the sport, especially for people with hand impairments who have trouble operating a traditional shifter. We are excited to explore all of the possibilities that this project presents.